Okay, so you watched a little video about an experiment with the volume of pyramids and cones, and hopefully you got a little bit of information out of that. So let's take a look at that information and take some notes on what we've seen. So, watch that Edpuzzle. We found out that a pyramid and a cone, I'm gonna flip my computer around here so I can actually, oops, take notes here. All right, we found that the volume of a pyramid and a cone, well, the pyramid or cone is 1/3 the volume of the prism or cylinder. That's where I asked you in there. Make sure you know that the volume of the pyramid is 1/3 of the prism, not 3 times. I know that's a mistake some people make sometimes. The prism is 3 times as big as the pyramid, but the pyramid is 1/3 of the prism. So that's how we figured it out. Now, this doesn't always happen. You can't just take any pyramid and any prism and make this happen. There are a couple things that have to be the same. And we noticed there that there was one thing in all of these that was exactly the same. What was that? So you probably noticed that one of the things that was always the same was the area of the base. Okay, they had to have the same base areas. In fact, the ones that we looked at, not even did they have the same areas, they were the exact same shaped base. Okay, you had a square pyramid, so both pyramid and prism had square bases that were exactly the same. Then you had one that was equilateral triangles, so both the prism and the pyramid had equilateral triangle bases that were exactly the same. And the cylinder and the cone both had the exact same circle base. Okay, the other thing that needs to be the same is the height. Okay, if the pyramid is way taller than the prism, that's going to change your volumes. Okay, so those are things that have to be the same. In fact, this actually leads us to a theorem that shows you don't even have to have the exact same shape. You just have to have the same base area. So two prisms or pyramids have congruent base areas and congruent heights. Then they have congruent volumes, even if the bases are different. So two pyramids that have the same base area and the same height are going to be congruent volumes. Two prisms that have the same base areas and the same heights are going to have congruent volumes. Let's take a look at a problem like that. Okay, so find the volume of both of these prisms. Now notice these are both prisms, no pyramids here. Okay, my sides of both of these are all rectangular sides. Okay, pyramids would have to have triangular sides. Okay, so that's a big note to make. Write that down. Pyramids have triangular faces. Prisms have rectangular or parallelogram faces. Okay, so here I have two prisms, and let's find the volume of both prisms. So I'm going to take this first one. I'm going to, since this dark side that's over here is a little darker, I'm going to call this my base over here. Okay. You know what? I'm going to change that. Let's not do that. Let's actually set the base on the bottom. So the base is going to be, let's see. Yeah, let's do this. Here's my base. It's going to be here. Okay, so since it's the bottom, remember that when you're dealing with a square or rectangular prism, it doesn't matter which one you call the base, but we'll make just to be easier, the base is the bottom. So the base of this thing is length times width. So that's 4 times 3, which is 12. So there's the area of the base, which is why I'm using capital B. Now the volume is area of the base times the height. So the area of the base is 12. And my height is this line that's perpendicular to the base. So that's 8. And 12 times 8 is, 96. Okay, so that's 96 cubic centimeters. Volumes are in cubic centimeters or cubic inches or whatever. Now let's look at this other prism. Okay, the base of this prism is not the bottom this time. Remember, the base side that's not a rectangle. So my base is this triangle here. So these two figures have two completely different bases. Shouldn't have anything in common, right? So the area of the base is 1/2 base times height, and the base and height this time are base and height of the triangle. That's why I'm using lowercase letters. So that's a 4 and a 6. So base equals 1/2 4 times 6. So that's a base area of 12. The volume, because it's a prism, is still base area times height of the prism, which is this side that's perpendicular to the base. So that's 12 times 8, which is, lo and behold, 96 cubic centimeters. Notice what just happened. Even though they have different bases, they have congruent volumes. What's the same? Well, look at what's the same. These heights came out to be the same. Okay, 8 centimeter height, 8 centimeter height. So they have the same height, just like we set up here. And in the bases, even though the bases are different, they have the same area. So that's a phenomenon that happens with volumes. As long as the base area is the same and the height is the same, you're going to get the same volumes, even if the shapes look different. Okay? That's just sort of a side note. We are talking about pyramids and cones today. And we did mention that a pyramid and a cone are 1/3 of their respective rectangular figures, their respective prisms. So in this case, notice what we have here. I've got my prism and my pyramid. Okay, let's see. The base of my prism is right here. So 4x3. So this base is length times width. So that's 4 times 3. So that's a base of 12. So the volume of this, again, is area to base times the height. So that's 12 times height of 8. Oh, look, same thing. Okay, same basic shape. Let's look at this next figure, though. The base of this figure is also a rectangle that is 4x3. So again, area of the base is length times width in this case because it's a rectangle. So that's 4 times 3. So the area of the base is 12. But the volume, because we are a pyramid, we have the same base areas, but the volume of a pyramid is 1/3 the area of the base times the height. So that's 1/3 of 12 times a height of 8. My height is right in here. It makes the right angle with the base. We're always looking for that. Okay. So that is going to be 1/3 of 12 is 4, and 4 times 8 is 32. And by the way, notice what happens there. 32 is 1/3 of 96. So there we go. So we learned the volume of pyramids or prisms and cylinders to basically be area to base times the height. So you can think of that as one thing, one formula. When you look at pyramids and cones, you're just adding a 1/3 in front of that. That's all it is. Okay. Something very simple with many, many different figures, and it's all the same thing. Your job is to recognize which one is which. Okay. Here we have a cone. So immediately, if I'm looking for the volume of the cone, volume is 1/3 area of the base times the height. But how do I find the area of the base? Well, it's a circle. Pi r squared. So there's my pi. My radius is 2.1. I'm going to square that. I'm going to go to my calculator for that one. So, oops. Let's see. Let's pull up my calculator screen. So let's get my Desmos calculator. Like to have a calculator handy. You don't have to worry about degrees or anything like that on this. So let's see. My measurements were 2.1 squared. So 2.1 to the second power is 4.41. So I'm going to write that in here. 4.41 pi. You know what? I'm going to leave it in terms of pi right now. I don't want to round too early because you have probably found that if you round too early and then use that later, it does change some numbers. We saw that on some problems that we did in our last volume Google Sheet. So, it was either there or it was in the review for area. So be careful of little things like that. So I'm going to take that now and put it into my volume equation. 1/3 area of the base is 4.41 pi, and the height is 6. Again, my height has to make a right angle with the base. Notice you also made a little right triangle there. Kind of cool, right? That could come in handy. Be careful. A lot of people will use this as the height, but remember, heights have to make right angles. So I can't use that as the height. I have to look at the vertical, or I'm looking for that right angle. Even if I turn this thing sideways, look for your right angle, okay? So now I've got 1/3 of that. But basically, I'm going to do a little arithmetic in my head. 1/3 of 6 is 2. So I'm going to double this. So 4.41 times 2 is that. And now I'm going to take that. Whoop, where did I get a 7 from? 82 times pi. Notice I started typing pi. It's a nice way to do that. So 27.7. Let's see what they told us to round to. 1 decimal. So I'm going to round this to 27.7, okay? Because 0 doesn't round the 7 up at all. So 27.7 is my rounded solution. Volume equals 27.7. I cannot write today. And by the way, your units there, centimeters cubed. And again, the units are cubed, not the number. I keep seeing a lot of people raising things to powers. Okay, you're using that little caret thing. I've seen at least 3 people raise things to powers instead of like multiplying by 2. Be careful. Okay, communication is important. So basically, all you really need to remember here is that the volume of pyramids and cones. Remember that the volume of pyramids and cones, when we need the, I don't know what I was supposed to be writing there. Volume of pyramids and cones are when we need the 1/3, not the prisms and cylinders. Okay, you need that 1/3 for that. Okay, one more. Volume of a cone. I tell you what, do this one on your own. Find the volume of that cone. Okay, so you said volume equals 1/3 pi r squared. That's a quick way to do that. So 1/3 pi, my radius is 5. Whoops, I forgot my height. 5 squared. And whoops, the height is not 13. How do you get the height? We've done a lot of this, okay? You've seen a lot of this happen. I can get my height simply by calculating my triangle there. So there's my h. You should have used Pythagorean theorem here to get that your height is 12, okay? I did that off to the side. So I'm going to put all that into my calculator. 1/3 of 12 is 4. I can just move my operations, move them around. So that's 4 times 25, and 4 times 25 is 100. So that's 100 pi. And you probably rounded that one just like we did the last one. So I'll just do that same thing here, times pi. I think that's 314.2, we'll call it. So 314.2 cubic meters. Hey, if you don't write the units, I'm not going to kill you for that. Okay. Remember, in your science classes, you need them. Units are important because we can look at the units and tell whether I'm looking at a length, an area, or volume simply by looking at the exponent of the units. When I see cubics, I know I'm dealing with volume. If I see meters squared, I know I'm dealing with area. If I just see meters, I know I'm dealing with length. So the units do tell you information there that I don't have to say in words. Okay, so a quick recap of the last 2 lessons. Volume for prism. Prism volumes are just the area of the base, capital B, times the height of the prism. Volume for a cylinder. You could do the same thing, area of the base times the height, or some people like to go pi r squared h. Look at it as a separate formula, but it's really the same thing. Volume for pyramid is 1/3 area of the base times the height. Aha. Volume for a cone is 1/3 pi r squared h, or 1/3 area of the base times the height. So that's really all you're doing. It's that area of the base that's important. That can be the kicker. That's the thing that changes. That's why we spend a little bit of time doing area first. In fact, let's look at a challenge problem. Let's take a shape that we don't have a formula for the area for. A regular hexagonal pyramid. We want to find the volume. So immediately I already know, okay, my volume is 1/3 area of the base times the height. I already know my height. I can see my height right in here is 20. Okay, so far, nothing crazy. 1/3, whatever the area of the base is, times 20. The catch is getting that area of the base. So let's go off to the side and work with that hexagon. In fact, I'm going to redraw my hexagon as best I can anyway. So here comes my hexagon. Hexagon has 6 sides. And notice we're told that this is 8. And it is a regular hexagon. What does regular mean? Hopefully you remember that regular means congruent sides and angles. A lot of people are only telling me congruent sides. It's congruent sides and angles. In fact, we could actually take this thing, and here's a little trick that I like to do to find areas. I'm going to take this and draw all my diagonals in. Because when I do that, notice what happens. I get a bunch of diagonals. Now, how big, or I get a bunch of triangles, how big is that little triangle? Well, all these triangles are the same. They're all congruent triangles. And there are going to be 1, 2, 3, 4, 5, 6 of them. How many degrees is all the way around? Okay, so if it's 360 all the way around, and I have 6 of them, how many degrees are in one of them? Good. Hopefully you were able to say that's 60 degrees. But remember, because all of these are congruent, these two parts are also congruent. In fact, all of these little pieces will be congruent. So if all of those are congruent, how many degrees are left for each of those? Remember what you know about isosceles triangles. What's the degrees of each of those? So hopefully you're able to calculate that each of these is also 60. Okay, now I've got something happening. In fact, I've got an equilateral triangle. So I don't know anything about hexagons when it comes to areas, but I know about triangles. So I'm going to now go off to the side and say, let me just focus on the equilateral triangle. Okay, where this is 8, I'm going to drop my height down here. That's 60. Heights have to make right angles. Ooh. Take a moment. Knowing what you know from some previous units, calculate the height of that triangle. Hopefully you're able to look at this and go, wait a minute, that's a 30, 60, 90 triangle. So that's 4, that's 8, this is 4 radical 3. So the height of that triangle has to be 4 radical 3. All right, putting pieces together, that's all we're doing. Taking information I already know, because I can find the area of a triangle. Calculate the area of the triangle. Area of a triangle is half the base times height. So that's half my base, which is 8, my height, which is 4 radical 3. So that's 16 radical 3. Not rounding yet, but that's the triangle. How many of those triangles make up my hexagon? Okay, so the area of the hexagon is 6 of this 16 radical 3. Okay, and 6 times 16, I got to do that here. 6 times 16, 96. Okay, so that gives me 96 radical 3, which is the area of the hexagon, which we also called the base area. Now I know my base area. I can go all the way back up to my volume and say, oh, 96 radical 3. And now I'm ready to calculate. Okay, let's see. 1/3 of 96, 3 goes into 96, 32 times. So 32 times 20 is 640 radical 3. That would be my exact volume. And let's see if I calculated that. Let's see, 640, good. 640 times square root of 3 is 1108.5. Let's go with that. 1108.5 cubic centimeters. So that is a complicated problem, but you know everything to be able to do it. Break it into simpler problems. Key to mathematics. Take a problem that looks difficult, make it into easier problems. I don't know the base area. I don't know how to find the area of that, but I can break it into a simpler shape, triangles. Once I break it into triangles, I kind of realize and play with it and figure out what I know about it, find out that each triangle is equilateral. Once I have that, I know things about triangles and figure my way through. Okay? So that's a good challenge problem. You may see something like this. I may throw one of these at you. You don't see too many of them, but it is a good one to sort of separate those that have a good understanding or those that just sort of memorize formulas and plug in numbers. Okay? So you've got some work to try. Give it a shot. I'll see you later.